Welcome to another episode of Xa Talk Show. You are watching Xa Talk Show, and today is 2020, May 17th, 2021, May 17th. And today we are going to do the first 30 minutes or so. We are going to do Emacs Lisp coding, live coding of Emacs Lisp. And on the pink window on the left, you can see all my Emacs command calls. Because if you are new to Emacs and if you are Emacs user, remember that in Emacs, the keystrokes is the critical thing, the primary thing. Every keystroke is ultimately calling a command. So you can, on the pink window, you can see all my keystrokes I'm typing. For example, let's see a new page, okay, except insert. Anyway, so you can see all my keystrokes, moving cursor forward by word, backward by word, or down, up, or jump by paragraphs. And you can see the corresponding command names. So if you don't know what I'm doing, you can always search for the command name, and you can find the code. For example, start beginning line of block, copy it, and type it here, and search. GitHub problems, GitHub, there it is. Well, so the code is, where is the code? The code is Xa Talk Show. The code, okay, the code is actually in my Xafly keys. Yeah, so here, there's an issue. I guess the search engine is not so good. What's the issue? That's a very old issue. 4 years ago, but anyway. So you can search for the command and find it, okay? Find the source code. Okay, so we are going to code Emacs Lisp. Okay, if you have comments and questions, post it on the side panel on the live YouTube. Okay, so let's begin. So first thing I want to do is to code a Emacs Lisp command. Let's see. Let's start a Emacs Lisp eLisp. Okay, let's start coding and let's show this in browser. Okay, let's start coding. So define. We don't have people here yet. So what does the command do? Convert seconds to minute, second format, or vice versa on current word. Okay, or vice versa on current word. Okay. Okay, and let's put the date, version, today's date. Okay, we are going to write this command, and okay, let's do so the what we want to do is that for example, let's say what's going on? So what? What? Oh yeah, so here is a number. For example, I want to convert this to a number of minutes and seconds. So let's do, okay, so the input is a number. Okay, so first of all, we want to grab the word under cursor, so which is a number. Okay, so how do you grab word number under cursor? I believe it's current word. Okay, let's see if that's the right function. Yes, indeed. So describe function to look up current word is a comparative function. Blah blah blah. Current word optional. Strictly really word. Return the word at or near point. Okay, as a string. Okay, so that returns the current word. For example, current word. Okay, so let's do this. So then we want to print the current word. Okay, that is basically our code. For example, I mean, let's just testing. Okay, the function name will be convert seconds to min sec. Okay, so copy that. So evaluate the buffer, then let's put a random number. Okay, here 8428. Now we want to put the cursor there, call the command, meta x, convert second to millisecond. Okay, press enter. Symbols value as variable is void, current word. Okay, so what's going on? Symbols value is what? Oh yeah, so here this should be that. Okay, let's rename this word x. Okay, evaluate the buffer. Now put a cursor on this word, coed. Let's magnify. Okay, coed, and you can see the message buffer prints it. You see, that's what the code does right now. So we want to. So that's how you grab the word. But actually, we don't want to use this function, this current word function, because our command is going to turn this into. Okay, let's change another number. Let's say 70. So if the cursor is on the word 70, it should return 110, 1 minute and 10 seconds, right? So, I mean, it should just replace the word, the 70 by this 110. So that means we need to know the we need to delete the 70. And in order to do that, we need to know the beginning position of the word and end position. So this current word function does not do that. It only gives you the word under cursor. So what do you need to do? So you need to call thing at point instead. So thing at point is part of the Emacs Lisp function. Okay, so thing at point takes a symbol as arguments. So if you say word, it will return a word. So this function is basically the same as that, and that's not what we want. What we want is bounds of thing at point. Okay, this is getting complex. Bounds of thing at point. So what does that do? It basically is the same thing. Okay, same thing as thing at point, except it returns the boundary. That is, it returns a const pair. Two elements. The first element is the beginning position. Second element is the end position of the word under cursor. So, okay, so that's what we want. Okay, so let's add new more variables. boundaryx. So let's name it boundary x. So set boundary x will be that. Okay, then let's add two more variables, position 1, position 2. Okay, then set position 1 will be car boundary. Car means the first element of a const pair. So boundary is a const pair, two elements. So that's the position 1. And set position 2 color boundary x. So that's P2 is position 2. Okay, now we want to get the word. So now we have two positions. We want to grab the string between them. So how do you do that? Set word x buffer substring no properties. Okay, it takes two positions, P1 and P2 exactly. Good. Okay, that's our code so far. And this line we no longer need. Okay, so now we have the boundaries, we have the beginning position P1 and end position, and we have the word. Now we can do. So now what we need to do. So the word x is a string, which actually is a number. Okay, we need to convert the type string to number. So string to number. Okay, there is such a function. So string to number word. Okay, then okay. So actually, let's clean up our code so it's all better. You see? So instead of that, we want to say this instead. Okay, so actually let's make it prettier kind of. Okay, so now word x is a number. So so it's not, let's say seconds. Okay, so actually, so yeah, let's make the codes easier to understand since I'm doing kind of tutorial. So let's be elaborate with all the set. You know, we don't need that many set actually. So anyway, so here's the seconds. Now we need to turn the seconds into minutes and seconds. So we need to first of all add another two variables, min x, sec x. By the way, why do I name my variables this way? Because I prefer to have variable names that is unique, that tends to not to be a English word. For example, the word x can simply be named word, but if but when you need to search the variable word, you tend to find lots of places that's not a variable. So in this way, word x is kind of unique. You'll just find the variable name. So that's why that's a preference in naming of variables. And same thing for functions. That's my own preference. So now we have the seconds. Now we need to turn these seconds into minute and seconds. Okay. Any comments? Hello guys, Ruby. Good evening. Central Europe. Fantastic. Hello everyone. Sid and Potato. Hello. So second. So now turn the second to minute and seconds. How do you do that? What you need is mathematics, modular arithmetics. Okay. So how do you do mod in Emacs Lisp? For example, in Python and many languages, you do that. So you have 70. The percentage sign is an operator, you know, so you do that, then you need to get the remainder. So, but I don't remember what's the function in Emacs. So go to XR Emacs tutorial, just search for it, you'll find it. Emacs Lisp, okay? Emacs Lisp basics, magnify, and go down, arithmetics. So here is the division, here is the integer part of a quotient, and here is the remainder. Okay, that's what you need. That's what we need. Close it. So I'm using my own tutorial as a reference. So integer part, so minute, okay. Set minute x, minute, not to be confused with minimal. So let's say minute x. And let's change the second to seconds x. Okay. So we have, so set minute will be mod. Okay. So minute will be mod. Wait, the second must be, okay, total seconds. So first of all, you have total seconds, then means yeah. So let's name our variable like that. Okay. So here, this will be total seconds. So the minute will be total seconds divided by 60. Okay. Prettify the code. Then set okay, so let's okay, then we set the seconds. Seconds will be the remainder. Okay, yeah, so that's that. Yeah, so here then total seconds divided by 60, right? So that's right. So delete, prettify the code, and we don't so the 70 example input. Okay, and here is example output. Okay, so now we have the minutes and we have the seconds. All we have to do now is to delete the original text and insert the new minute and second. So let's do. So before we insert, we need to delete. Delete region, okay? 2 positions, that's right. P1 and P2, beginning position and end position, those are numbers. then insert. So insert, we will be inserting, okay, let's say format. Okay, then two variables, minutes and sex. Okay, so hold on a second, sex. Okay, then there it is. Okay, now we don't need this message part. Delete it, prettify the code. Fantastic, I believe that's it. That's the whole function. Actually, we haven't done the vice versa, the reverse conversion yet. But first of all, so this is, I believe that's it. So let's verify before, let's avoid trial and error. So minute, then seconds, those are, oh, actually, yeah, that's right. So minute is the quotient, seconds is the remainder. That's right. So let's try it, okay? Evaluate the buffer. Let's show the pink window. Evaluate the buffer. Then let's call, let's just put 70, okay? 70, put the 70, then call the command. Convert second to minute sec, okay? Press enter, we should get 1:10. Let's see. Do it. Ooh, fantastic. Complete, guys. Let's try some bigger number. Let's say 701. Let's see what happens to that. Okay. Now this is just like testing. Okay, do it. 11 minutes and 41 seconds. That's probably right. Okay, so that's, yeah, well, it seems right. So let's try another example. 59. Okay, do it. 0:59. Fantastic. We presume this is correct. No need further testing. Okay, now this is done. The next thing we need to do is write another function or modify this function so that it can convert the reverse way. Okay, I'm going to read the comments, take a break, but let me tell you, so now there's an interface issue. Now you have to make a decision. One is that use the same function that do both, by pressing a universal command. So if I want to convert from minute second format to the second format, I call the same function except that I press Control U first, then I call it. Then I'll do that. So that's one option, using the same function. The other option is just write a new function. For example, writing a new function. So this, writing a new function, and so which one should we do? I'm going to use the same function. There are pros and cons in either case. Okay, I'm gonna use the same function. The advantage is that it's just one function name, and the function can automatically detect whether the word or the sequence of strings under cursor contains a colon or not. So if it contains a colon, then we know we want to convert it to seconds format. If it doesn't, we know which way to convert. So I'm gonna just use a function, one single function for it. Fantastic. Now let's read the comments. Howdy. So Scott, hey Scott, haven't seen you for a while. It's doing pretty good. I did my taxes yesterday. Now that's after 16 years of no doing taxes, because I don't make enough to do taxes. But yesterday I did taxes, and now I'm going to get $1,800 from federal government, and I'm going to get and plus something like 2,000 stimulus, COVID-19 stimulus money. My life has been changing for the better. The turning point is 2020, and the reason, my mom died. A sad story, but it's a bit detailed, okay? I'm not going to go into. So have you played with Emacs 28's ability to do native JIT, just-in-time compilation of Emacs Lisp. No, I haven't played with Emacs 28. That would be a great feature. I haven't played. I'm getting old. I haven't played with these things. I'm just wait for the day when it come out, and I just install it, and it works. I don't. I'm not too. Unlike when I'm younger, we are getting old, Scott. And Scott, by the way, Scott is C and C++ programming language expert working on CPUs and GPUs and the textures, designing CPUs and GPUs. So anyway, so let's finish this. Let's do the reverse conversion, and maybe that's it for today. I've been talking 23 minutes. Okay, so maybe today is just gonna be pure Emacs Lisp, no random, sensitive topics, random, stuff. Okay, now let's do the reverse conversion. So first of all, design the interface. So how do you want it to be? So let's write documentation. Let's explain. So convert seconds to to minute-second format or vice versa on current word. Okay, now explain. If the current word contains a colon, then do the reverse, do the reverse direction conversion. So it's basically automatic. It will automatically detect which direction to go. Okay, that's what we decide. That's the user interface I decided to do. So now comes to the coding part. How are you gonna do this? So first of all, we grab the word, we grab the boundary, then we got the word. Now we need to put an if statement. Okay, if something, we want to see, check if word X contains colon. So that's what we need to do. Okay, but before we do that, there's an issue, because when you call bounds of thing at point, I was eating something in my teeth. So when you call bound of thing at point, will it grab the whole minute and second part? So what I mean by that, for example, if you have this, let me just code it. Okay, so it's easier to instead of me spending several minutes to explain. So let's comment this out. So now let's just print word X to see what it returns. Okay, when to see what this thing at point actually grabs. I mean, the question is, will it just grab part of it, or will it actually consider the whole thing as a word? Yeah, actually I know the answer, because the thing at point, the thing at point package, I don't like it, because it, okay, it's a bit more complicated, because Emacs, in Emacs and Emacs Lisp, they have the concept of syntax category. Okay, let me quickly explain this. So if you go to the Emacs Lisp basics, you go to the so you go to the more advanced Emacs Lisp writing a major mod. Okay, then you will see this section about define phase, syntax coloring, syntax table. Okay, so in Emacs Lisp you have this concept of syntax table. What basically it means, it classifies each and every character in Unicode into groups. For example, all the punctuation characters, comma, colon, question mark, space, those are punctuation group. Then English letters, Russian letters, alphabets, and or Chinese characters, those are kind of another group. Words, letters, or words. Then you have another group that's what? Okay, let me concentrate. String, then you have another group about syntax classes. Okay, there you are. So you have white space characters, you have what's considered word, you have what's considered symbol, then you have punctuation class of characters, then you have string delimiters, then you have the left bracket, right bracket, and so on, then common character. So this is a feature built into Emacs Lisp or Emacs, how Emacs works. Each character is, every character in Unicode is classified into these kind of funky groups, okay? These funky groups is not mutually exclusive, by the way. For example, common start character, it can also, usually, for example, in Python, Perl, Bash, PowerShell, the common start is a pound sign. But in English writing, that pound sign is considered a pound sign or a number sign, or it's considered a punctuation. So sometimes the letter can belong to multiple categories, and also word and symbol. That's very confusing. Word basically means English word, and symbol means Lisp symbol. Basically, it means allowed characters in a identifier of a programming language. So anyway, in Emacs, it has the concept of syntax table, which is a table that classifies characters into each of these kind of the groups. And here's the thing: for each buffer, it can have its own syntax buffer. I mean syntax table. So depending on what major mod you are in, the same character may be classified into different groups. So for example, let's say the parentheses, okay? In Lisp, it's considered a left bracket. In English, for example, in fundamental mod or text mod, that's also considered a left bracket. But however, you can write a major mod for some language where the parentheses is not considered a bracket. Rather, it's considered, let's say a comma character. I mean, a string start character or something. So there's a lot of problems about the Emacs syntax table idea. It's pretty bad. Okay, this is a bad thing. However, it's very fundamental because every command that move cursor is dependent on the syntax table. So why is it bad? First of all, you have this classification, which is kind of fuzzy. It's not mutually exclusive, and even so, it's difficult to define them. To create a syntax table to say which character belongs to that group. It's a huge mess. Okay, so first of all, one of the problem of the syntax table is that it has these funky classification, categories, which is idiotic. Okay. So what's an example that's not idiotic? For example, the Unicode specification. Unicode. Okay, let me ramble. Okay, maybe let's ramble about these things. Okay, so we getting into linguistics and stuff. Okay, let's go to my Unicode page. Okay, just search for Xali Unicode. You'll find my Unicode page. So Unicode standards, they also have. Okay, let's magnify the browser. Hold on a second. So let's magnify the browser once for all instead of doing it on every page. Appearance, magnify 125%. Okay, so my Unicode page. So let's go down to the Unicode for programmers. Okay, so I have I have quite a lot of articles on Unicode for programmers, the technical details about Unicode, which is about characters, about languages, what's a Unicode, what's UTF-8, what's a code point, this kind of thing. So you go there and read it, if you are new to programming, okay? And I talk about encoding. So the thing I want to say is that Unicode has a way to classify each and every characters into letters group. into numbers group. For example, what do you mean by numbers group? For example, 1, 2, 3, Arabic numbering system, 1, 2, 3, 4, up to 9 and 0. But that's not all, because in Chinese, let me show you, okay? In Chinese, you also have, okay, in Chinese, you also use the Arabic numbers, like 3, for example, 3 or 5. But however, you also it also has its own, Chinese characters to represent 1, 2, 3. So, for example, this character, that is 1, okay? Actually, let me show you some other thing. Okay, so here's a Chinese text from Wikipedia about this poem. And you can see, here is 2 numbers, okay? Let's magnify, okay? So look at this. This is a number. It means 5, okay? And here is another number. It means 10. So in Chinese, it has its own number characters for number. So these characters also belongs to the group numbers, okay, digits, okay. Similarly for Arabics or Indian, different Indian languages, or many languages has their many languages has their own digits, their specialized digits. So when you deal with Unicode, all the characters or writing systems, in Unicode, that's what Unicode is. You have to consider these things, So you have a group for numbers, digits. Then you also have a group for punctuations. Then you also have a group. Okay, let me. So Unicode, we are talking about Unicode. So we are talking about the classification. I mean, the general idea, the concept. Everything about classification of characters into different groups. We started to talk about that because of the Emacs syntax table. So let me show you some other groups, categories. Okay, so you have letters. So these are our letters. In this case, Chinese letters, also including English alphabet, Latin alphabet, Spanish special characters, Spanish, French with carets and accent signs, German, umlaut, things like that. Those are all letters group. Then you have digits group. Then you have punctuations group. For example, you're looking at this character, that's a Chinese punctuation for period, okay? And here is a Chinese punctuation for comma, okay? So they both also belong to the punctuation group in Unicode, okay? Then let me show you other. So I want to show you other categories. Okay, so for example, sex, sex symbols. So what is this? So this is a character, right? And this character, it's in Unicode. It's in Unicode. Therefore, it also has a classification. So what's this group? It's symbols, okay? And also you have emoji. Then you also have. Let me show you some of the characters. For example, some of these crosses, okay? Some of these are ancient. For example, this ankh. And Chiro, those some of these are 2,000 years old symbols, and also the Christian cross, the Greek cross, and so on, and Israel sign, and so on. So these are also so there is a group to classify these. Okay, so I'm actually the one I want to talk about is. There is a one called letter-like symbols. Okay. Anyway, the best thing, I don't have an article for that. So the best thing is to search for Unicode character classification. Okay. Then you'll find there it is. A categorization of Unicode characters. They talk about details, how they assign categories. So anyway. So what I'm saying is that the Unicode, that's actually better categorization. Since I'm talking about this, let me show you some programming articles related to it, okay? So for example, XAR, so search for JavaScript in depth. Okay, that's my tutorial of JavaScript in depth. And you can go to JavaScript reference, okay, and go to JavaScript regular expressions, okay, regular expressions. Then you want to, so JavaScript regular expression provides a way for you to use regular expression to match or list all characters that belongs to a certain category. So how do you do that? Here, okay, regular expression syntax, okay, character class, okay, so you have character class, that's right. Somewhere here, okay, let's search for Unicode. Yeah, Unicode property. So it's called Unicode property. So you can, this is just a JavaScript regular expression syntax to match any characters of a specific Unicode property. The property is typically, property name and property value. So for example, let me show you an example, okay? So for example, I already have examples here. So if you want to get all punctuations, you can do this, okay? Here, so here's a full code you can run. So, okay, let's do this one, currency symbols, okay? Let's run it in Emacs. So open it, paste it here, magnify, save it, xx.js, okay? So you can see we have a string here. Here's our string. We want to grab all characters that's considered a currency symbol. Currency symbol is one of the Unicode category. So you run the code, run it. Uncode syntax error. What the fuck? Invalid regular expression. What? What? This is bad. Okay, this means my tutorial is wrong. What? Uncode invalid property name. Okay, maybe it doesn't support currency in my current in my Deno. I'm using Deno as a JavaScript engine, so I don't know what's going on actually. So this is bad. So let's try this one. So get letters, okay? So we have now 4 characters here. Now, okay, I'm getting, okay, let's just run it. Uncode syntax error. What's going on? Deno. Okay, Deno doesn't support. This feature is new. This feature is new in JavaScript 2018. Deno should support it by now. What's going on? Anyway, that's too bad. Okay, let's try this. Let's run this in browser. Then you'll work. Okay. So copy this. Okay, let's go to browser. Press F12 to show the JavaScript console. There it is. Magnify. Paste the code here. Run it. There it is. Okay. You see, it shows it return value is $2 because that's currency symbols. So out of this string, we want to get the currency symbols, and that works. Let's try some euro character. Okay, let's try some euro character. So let's try. Okay, so how did I just do that? That is magic. Okay, let me show you. Okay, that is the command xa input change to symbol, and that is in the package xamath input.el. So open it, magnify, magnify, magnify. So this is the Emacs Lisp package where you can type all hundreds of Unicode characters by using abbreviation. For example, all these triangles, squares, and currency symbols, and so on. So if you like it, use it. Okay, it's on Melpa. Okay, so let's go back. Wait, open it. Let's. I want to go to my talk show and write a note about it. Okay, so as a documentation of what we talked about. Okay, so save it. Let's go back. Okay, so anyway, so digression, close that. Let's go back to, yeah. So now we type a euro, copy the code, back to browser, magnify, paste the code here, return, enter. So you see, it got euro. So that's about Unicode categorization of characters. Okay. Now back to the Emacs Lisp. You know, the Emacs idiotic. Where do we go? Yeah, let's go back to Emacs. Yeah, Emacs syntax table. So in my opinion, Emacs syntax table is pretty lousy. But however, it's hard to change because it's very fundamental. It sits in the core of Emacs. So anyway, that's here is a tutorial about Emacs syntax table. So back to where we were, what we were doing. So we were doing. So close that. So we were doing. Let's go back to our code. Okay. Sweet. Okay. So let me read the comments. Ask 96. I will give a short summary of what's wrong with Unix and C. Okay, so let's go back to the code. Okay, so what I was saying is that, did we try this yet? Okay, so yeah, let's try it. Okay, we want to know if this bound of thing at point, you know, we tell it to grab the current word under cursor, but we want to know what does it consider a word. For example, I know that digits, sequence of digit, we will consider as a word, but probably not the colon sign. You know, in Emacs syntax table, it will consider that as a punctuation, so it will not do that. So we can try it. Okay, eval the code. Now show the message buffer, then call the command on this text. Okay, I put a cursor here. Okay, call it. You see, it returns 41, which is not what we want. So that means, you know, because we want to grab the whole thing. So that means we need to change this bound of thing at point. Okay. So instead of calling that, we need to do it manually. So let me show you how do you do it manually. Okay. So let's okay, okay, we're gonna finish this and that's it for today. So today is just Emacs Lisp. Okay, so how do you do this? We want to replace these lines of code. Basically, these lines of code. We want ultimately get the current word under cursor. Okay, so what do you do? That let me show you. Okay, save excursion. Okay, I'm gonna ignore that. Okay, look it up. Okay. It's in my Emacs tutorial. So what I want to do is search backward. Okay, search backward by space. Okay, bounds. No, we don't care. We don't care. Search backward by space. That will move cursor, you know, backward until it finds a space. Then forward char. Okay, I'm just going to do this quickly. Then set P1 point. Okay, so move the cursor backward until it finds the space, and it will skip it. Okay, then forward one character. Then that's our beginning position. Okay, then search forward, and I'm going to do this fast. Okay, so search forward, we don't need that. Then backward char, search forward by regex. Okay, research forward. Okay, so it's either a space or a actually I should use that. Okay, let's not do that. Let's just do that. A space or return. Okay, line return. Okay, so space or line return. Okay, so let's do it. Let's not worry about complex situations. Okay, then search forward by that, then backward character 1. Okay, then set p2 the point. Point is the position of the current cursor position, which is a number. Okay, integer. Okay, so that's it. Okay, so this block gives us the P1 and P2, beginning and end position. Now we have that. Once we have that, everything is easy. Okay, now we just do this, grab our word. Okay, so instead of using the bound of thing at point, because it have problems with the colon, we manually code it this way. Okay, then that should be it. Okay, so now we evaluate the buffer. Now we show the message buffer. Okay, now watch the end. Okay, now we're gonna call the command on this part. Okay, okay, so I'm trying to, okay, so call it, do it. It worked. No, no, it also grabbed the example part. Okay, so what it grabbed is this whole thing, which is not what we want. Okay, so there's some error here. This is search regular expression, search forward, space, or for simplicity, let's just say space. Okay. Oh. Here is the what's wrong. Okay, we got this line we don't want. Okay. So again, eval the buffer, try it again, call it, do it. Now it grabs the, okay, now it grabs the two right parentheses. Okay, what's going on? Space or, let's just do simple one, search forward. Okay, search forward by space. Okay, comment this out. Okay, we are assuming we're gonna have a space here. Some, okay, let's, so okay, evaluate the buffer, put the cursor here, call it, do it. There we go. We got the 11.41. Now, why do I fuss about these things before? Because if you just have, for example, if you just have that on a line by itself, there's no space afterward. Turn on show space mod. So there's no space, then your code will not work. That is why I was, fussing about, tweaking it so it works well. But for now, let's not worry about it. Turn off space. Okay. So let's continue. Okay, so let's continue. So once we got, so far so good. So far so good. Now let's go back to our code. Now we don't need this anymore. Delete it. Okay, let's leave it. Okay, actually leave it so other people can see what we tried. So now we got the word. Now we want to check if the word contains colon. Okay, if string match colon, and our string is word X. Okay, so if that is true, then we want to convert the minute second format to the seconds format. Otherwise this code will work. Okay, otherwise run this code. Okay, so let's put that there. Okay, pretty fine. Okay, so for now, so now, but what if it's a, so how do you do that? So here we need to convert minute second format to seconds, to all seconds. So let's code fast. Let's just do this. So split string word X. Let's see the documentation of split string. It returns a split string into substrings bounded by match. Okay, it returns a list, I think. Okay, let's do this fast. Okay, let's just say list x, okay? Add a variable split string set list x split string separators. Oh yeah, we need separators, okay? Separators will be comma, okay? Omit nulls. We don't worry about that. So put it here. So first of all, we split string, then we have two parts, okay? So the first element, so how do you get the element of a list, the nth, okay? Nth 0 list x. Okay, let's use a let, okay? Let okay, yeah. Set minute x equals to that, okay? Then set seconds to nth first element, which is also the last element. Okay, so we got minute as second. Then multiply minute by 60, then add. So this is where the parenthesis syntax is painful. Okay, can you guys see this? Okay, I guess now you can. Okay, so that's your total number of seconds. Then, okay, then delete region, P1, P2, then insert, format, that. Okay, I think that's it. Yeah, I don't know. I don't know for certain. Let's hope. Shrink. Let's remove these. Okay. Okay. Now that's our code. Okay. Let's hope it works. Evaluate. Now, first of all, let's try working on the 70 to see the old behavior still works. Co-ed. Fantastic, 110. Now let's try this 1141. It should return 701. Okay, try it. Oops, wrong argument type. Number 2 or mark P here. Oh yeah, because remember we have the space problem. So let's try it over here. Okay, do it. Okay. Number or mark P, wrong argument. Okay, so what's going on? Wrong type argument, number or mark 11. Undo. So what does split string returns? Okay, so we are almost done. Yeah, so it returns a list. Okay, so because it says there. So it returns the list. What about nth? Nth returns the nth element. That's right. So minutes is the 0th element. So split string. Let's just print. Okay, let's let's debug. So these print are debug. So let's evaluate the code, show the message buffer, call the command on that. So we got minute 11, second 41. Okay, we got the input correctly. We grabbed them correctly. So something wrong about the output. I mean something wrong after that. So far so good. Delete region P1, P2. It should be good. Then the format part is wrong. Okay, I believe. Wrong type argument, number or marker, 11. So 11 is the minute part. So, oh yeah, so the minute part, that's right. It needs to be a number, but however, what we have here is a string. So we forgot to convert string to number, okay? So here, we just need add string to number, okay? That's what we need to add. And same thing for here, string to number. Okay? Then we don't need the comments anymore. Do it. Eval buffer. Put a cursor on this over here. Call the command. Do it. Fantastic, 701. And let's call it again, okay? Let's call it again so that it convert back to 1141. Do it again. Oh, fantastic. Complete, mission complete. Now, of course, we can clean it up so we can cover situations where when you have, you know, that by a line by itself. In fact, I think this should work. I don't know. Let's just call it. Do it. No, it doesn't work. So search for word. Let's see. Search for word. Regular expression. Search for word. I don't know why that's not working. But anyway, we have the. Let's read the comments and maybe that's it for today. Get line, get paragraph. What are are there? So Dion says, are there no built-in functions for get word? Yeah, okay. You are late, Dion. We talked about that before. That is, there are two. You know, if you watch the video, so there are two built-in ways. One is current word. You know, the function named current dash word. That gets you the current word under cursor. And another way is thing at point. However, we cannot use those because we cannot use current word because two problems. One, we need the boundary, okay? We need the beginning position and end position because we need to delete the word. You know, we not just only need the word, we also need the position because then we need to delete them, you know, replace it, delete region. So we need the boundary, therefore we cannot use current word. Now, but we can use thing at point. You know, we talked about this in the beginning of the video. Thing at point, we tried everything. Thing at point, that gets you the boundary, but there's a problem about the syntax table because it does not consider colon, you know, as part of a word. So it will only get 41 or only get 11. You know, so we have to code our own manually. Okay, that's it for today. Thank you. Thank you guys. Well, if you like my Emacs tutorial, you can buy it. You know, sponsor me for my trouble. Emacs tutorial, you go there and you can easily find my where you pay. Okay, so buy my Emacs tutorial, or you can PayPal me, Amazon gift me, or Patreon. Okay, so Dion's question, so not get word, okay? Actually, you should look, watch this video because we spent like 10 minutes on those. The function name is, let me just type it, okay? here's a function, okay, current word that grabs the word under cursor, but however, it doesn't give you the boundary positions. Also, it doesn't deal with the colon sign, so we cannot use that. The other thing is thing at point. Okay, so that's a function name. So you can say thing at point word. It has the same problem with current word. And however, if you want boundary, what you say is bounds of thing at point. Okay, that's a function. And this version returns the boundary. But again, it has a problem of not getting the colon sign. So actually, I talked for 20 minutes about Emacs Lisp syntax table. It has to do with Emacs Lisp syntax table and categorization of letters. Okay, that's it. Thank you guys for watching. So today is all pure Emacs. Bye guys. Yeah. Oh, 17 people. So we have quite a lot of people today. Okay, so how long have I been talking? Yeah. 1 hour. Okay, shut down. Bye guys.